Welcome Algebra 2. This lesson's on 11.2, probability. The essential question is, what is probability? Let's begin. So a few notes about probability. It's what measures how likely it is for an event to occur. And some of the rules of this, probability of an impossible event is 0 or 0%. That means it's not going to happen at all. The probability of a certain event is 1 or 100%. So it's definitely going to happen. The probability of any other type of event is between 0 and 1, or between 0% and 100%. So basically your range is down to 0% if it's never going to happen, all the way up to 100% if it's definitely going to happen. So looking at these probabilities, which of these probabilities is possible? 120%, 5/4, and negative 0.54. The answer is none, because 120 is over 100%, so that's too big. 5/4 is the same thing as 1.25, which is bigger than 1, so that's also too big. And probabilities can't be negative numbers, so none of those work. So let's talk some vocabulary words. When you gather data from observations, you can calculate something called an experimental probability. So this is the probability just from the results you got. So experimental probability, and we have this notation, P parentheses. So P stands for probabilities, and in parentheses, this is the probability of what event. So that's what happened. And that P out here stands for probability. Prob. So it equals the number of times an event occurs divided by the number of trials. So the number of times it happened divided by how many times you did it. So here's an example. Of the 60 vehicles in a teacher's parking lot today, 15 are pickup trucks. What is the experimental probability that a vehicle in the lot is a pickup truck? Well, you do this probability of pickup truck. So I'll go probability of pickup. It's going to equal the number of times the event occurs, and that event is it's a pickup truck, and that's 15, divided by the number of trials. Well, there's 60 vehicles total. So 15 divided by 60, which simplifies to 1/4. So that is the experimental probability. Simulation. So sometimes actual trials are difficult because you're talking about millions and millions, or you're not in the right place, or you don't have the right tools. So you conduct something called the simulation. In these situations, you can estimate an experimental probability using a simulation. Simulation is just a model. And one way to do this is usually with computers. I know you can't do that at home watching this video, but just try to follow along with what we're doing here. So on a multiple choice test, each item has 4 choices, but only one choice is correct. So A, B, C, D, like only one's correct. How can you simulate guessing the answers? What is the probability that you pass the test by guessing at least 6 of 8, 10 answers correctly? So how can you simulate? And one way is using a computer. And there's random functions, and hopefully we can go over these in class, where you can just generate random numbers. And let's say that it was generating random numbers between 1 and 4. And every time you answered number 1 is correct, but the other numbers are wrong. So in this case here, they've already generated a bunch of random numbers. So 10 questions on a test. So the first guess was 3, 4, 3, 1, 4, 2, 1, 2, 1, 2. And since there's only 3 ones in that, that means they only scored 30% of the questions right, or 3 out of 10. And then here's the other 19 simulations. So this is one way to get 20 examples. Of these 20, only one test actually had 6 out of 10 answers correct, and that was this one. So if you want to figure out the probability of passing based off the simulation, number of passing tests divided by number of tests taken, so that would be 1 passing test over 20 tests total, so 1/20th is your answer, or you can write that as 5% from that simulation. So other vocab words you might hear, sample space. This is the set of all possible outcomes of an experiment. So this is all the answers. And so for the last one, the sample space would have been 1, 2, 3, and 4, because those are the only possible outcomes of your answers. Equally likely outcomes. So this is when each outcome has the same chance of occurring. So an example of that is when you roll a 6-sided die. So there's 6 sides, and if you rolled it, gave it a good spin, each side has an equal chance of coming up. Also like flipping a coin. Heads or tails. You flip a coin, it's basically 50-50. So those are equally likely outcomes. Now theoretical probability. So this is another big concept for this. So if a sample space has n equally likely outcomes, and they're equally likely, and an event A occurs in m of those outcomes, then the theoretical probability of event A is probability of A equals m divided by n. So it's kind of the same concept, but of what we were doing with those simulations and those data, but your M is the number of times the event happened, N is the number of times the number of possible outcomes. So let's do these examples. What is the theoretical probability of each event? Getting a 5 on one roll of a standard number cube. So this is 6-sided die. That's 6-sided die. So you're going to roll it once and you get a 5. What is the chance of you getting a 5? Well, let's write that out. The probability of a 5 is going to be, well, there's M is the number of these outcomes. Well, there's only one outcome that has a 5 because only one side has a 5. And then N is the number of equally likely outcomes. Well, each 6 of the 6 side is equally likely, so it's 6 on the bottom. So your probability is 1/6, and that's the chance of getting a 5 when you roll the die. Now for B, getting a sum of 5 on one roll of 2 standard number cubes. So you're rolling 2 dice here. So I'm going to say the probability of the sum of 5. Okay, and so you have to figure out a few things. You have to figure out what are the possibilities where you actually get a sum of 5. Well, let's do a little table here. So we'll do number 1 and number 2. So if you roll a table, which possibilities have 5? Well, if you roll a 1 and a 4, we roll a 4 and a 1, or a 2 and a 3, or a 3 and a 2. So these are your only options where you'd get a sum of 5. So there's going to be 4 options. Now, how many total different combinations are there? Like how many different things? And I can make this chart and figure this out, but we can also go back to last section and say, well, you're rolling 2 dice, and then we can go back to our concept before. So how many different combinations? This is the counting principle. It's going to be 6 times 6 because you're rolling 2 dice, and each dice has 6 different opportunities. So that's the fundamental counting principle. So the total is going to be 6 times 6, or 36 different combos. So 36 on the bottom. So your probability is 436, which simplifies to 1/9, and that's your answer. Let's try something else. So similar idea here. A batter's strike zone depends on the height and stance of the batter. So this is the strike zone, a rectangle. And what is the geometric probability that a baseball thrown at random within the batter's strike zone will be in the high strike? So what's the probability of this whole rectangle, if the baseball is going to hit one random area of this strike zone, that it hits this square or that rectangle? And so what you're going to do, probability of we're going to call this a high strike. It's basically the area of that little box divided by the area of the big box. So the area of the little box is going to be 4 times 6 over the area of the big box, which is going to be 22 times 17. So 4 times 6 is 24, and 22 times 17 is going to be 374. So, and we can leave it like that, or actually let's try to reduce that. And if you can reduce both the top and bottom by 2, so you can divide both top and bottom by 2, and the simplified form is as 12/187. That is your probability. That's it.